In the previous video, where we walked through the mechanism for how to make diazonium ions, you'll notice that we started with a primary amine. The amine had 2 hydrogens on it and only 1 carbon. If the nitrogen is only bonded to 1 carbon, the amine is called primary. Just 1 carbon. Let's think about what would happen if you tried to do this reaction with a secondary amine. These first steps are between the sodium nitrite and the hydrochloric acid. So these would happen exactly the way they did before. You would protonate the oxygen, one of the oxygens in the nitrite ion, twice, so that it turns into a good leaving group, which then leaves, so you'd still get your nitrosonium ion. When the other nitrogen of the amine attacked, it was the lone pair that attacked. So here, it won't make a difference whether there are hydrogens or not. So you'll still form this molecule. And this next step is just a water stealing a hydrogen from this amine. Now, if you have a secondary amine, where instead of a hydrogen here, you have another carbon chain, you could still steal the 1 hydrogen on that secondary amine. And so you would end up with this product here. But you'll notice that if you try to go further, and this next step is actually an equilibrium, if you try to go further, the reaction only proceeds if you can steal a second hydrogen from that amine. If the original amine only had 1 hydrogen, so that was not a hydrogen there, but rather another carbon chain, then the reaction could not proceed beyond this step. Now sure, you could protonate this, but that then wouldn't react at all, and so the majority of your product would be this right here. This is called an N-nitrosamine. You have a nitro group attached to the N, the nitrogen of your amine. So N-nitrosamine. If you start with a secondary amine, then you get an N-nitrosamine. If you're trying to predict the product, you would erase the hydrogen on the secondary amine and fill it in with a nitrogen double bonded to an oxygen. Okay, so let's review what we just said, organize it a little bit. If you start with a primary amine, so the amine you have is only bonded to 1 carbon, so it has 2 hydrogens, then we can go the whole way along the mechanism that we just talked about, all the way to the end. And we would get the diazonium ion with 3 bonds between the 2 nitrogens and a full positive charge on the nitrogen bonded to the carbon, like we would expect, the diazonium ion. But if we have a secondary amine, we can't go the whole way. Instead, we're going to get stuck at the N-nitrosamine. So we would replace that hydrogen with a nitrogen double bonded to an oxygen. And that's one of the oxygens from the nitrite, the one that wasn't able to leave. So this is a diazonium ion, and this is an N-nitrosamine. Now notice, we're treating these with the same reagents, but they get either further along in the mechanism that we drew in the previous video, or not as far along, depending on whether you have a primary or a secondary amine. But we can use that piece of information to predict the products in exercise 2129. Here they're saying, predict the major product obtained when each of the following amines is treated with sodium nitrite and HCl. That recipe will turn a primary amine into a diazonium ion, and a secondary amine into an N-nitrosamine. Okay, so I'm going to draw these reagents in. We have sodium nitrite and HCl. So what would we get? Well, we'd take this molecule, and we'd replace, and here, I'll put this in separate colors so we can sort of see that adding. We'd replace the 2 bonds to the hydrogen there with 3 bonds to the nitrogen from the nitrite. And that first nitrogen will have a positive charge. So in this case, because this was a primary amine, this nitrogen is only bonded to one carbon, we formed the diazonium ion. Compare that with what happens in with the next molecule. Here, everything is the same, except we have a secondary amine. This amine is bonded to 2 carbons, right? This one was only bonded to 1. So we have a secondary amine. And that means that this will only be able to form the N-nitrosamine. So where the hydrogen was, you'd erase that and draw in a single bond to a nitrogen double bonded to an oxygen. That's the N-nitrosamine. And that nitrogen there is the nitrogen from sodium nitrite. And the oxygen is from sodium nitrite too. It was the one that we couldn't get to leave. Okay, let's use that same recipe on another amine. And what you'll notice in this amine is that it is secondary. This nitrogen is bonded to 2 carbons, so it is secondary. That means that if we treat it with this reaction, if we treat it with that recipe, it will only go so far in the mechanism to create the N-nitrosamine. So we can erase the hydrogen and form a bond to a nitrogen double bonded to an oxygen. And that would be the N-nitrosamine that we would get in this step. All right, let's try one more. We take that same recipe, we treat an amine with it, and what you'll notice about this amine is that it is secondary. The nitrogen is bonded to 2 carbons. So it's a secondary amine. That means it will only go so far in the mechanism to form the N-nitrosamine. You won't be able to kick the other oxygen of the nitrite off. So where the hydrogen was, you'll add a nitrogen double bonded to an oxygen. And that would be the N-nitrosamine that we get there. So in this exercise, we've seen that if you go through the mechanism that we went through last time, that diazotization mechanism, you'll get a different product depending on what type of an amine you use. If you use a primary amine, you'll get the diazonium ion, which we said was really useful because this is an amazing leaving group. And that's what we're going to use in future exercises. But that will only work if you have a primary amine. If you don't have a primary amine, if you have a secondary amine, you can only get as far as the N-nitrosamine. And N-nitrosamines are really interesting compounds. I encourage you to Google those. They're in things like, they're carcinogens mostly, but they're in things like beer and bacon, and so they're interesting to read about from a health perspective. But from a synthesis perspective, that's where we would be limited if we use a secondary amine. So as we use these diazonium salts in future exercises, remember that we can only make them if we start with a primary amine.